This video covers section Probability F. It's the last video for the probability module. In this video we're looking at permutations and combinations. Now firstly, let's look at the definition of a permutation. A permutation is an ordered arrangement of items. Now when listing all permutations of a set of items, it's important to be systematic. So what I'm looking at here, what are the possible permutations of the letters A, B, C? And you might have remembered doing this when you're at school. So you can have A, then B, then C, or you could have A, then C, then B. Next, you could have B first, then A, C, or B, then C, or then A. Or you could have had your C come first, which would have given A, B, or C, B, A. So you've got 6 permutations. Now the thing to note here is that order matters. Just because I've got the same 3 letters, if they're in different orders, that makes a difference. Next, let's look at factorials. Now the number of permutations of a set of n items can be written as npn. And that's equal to n factorial, which is written as n exclamation mark. And what that means is n factorial is n times by n minus 1 times by n minus 2 times by n minus 3. Keep going until you get 4 times 3 times 2 times 1. So if I had 7 factorial, it'd be 7 times 6 times 5 times 4 times 3 times 2 times 1. If I had 4 factorial, it'd be 4 times 3 times 2 times 1. Okay, note that 0 factorial is equal to 1 and that npn is n factorial. So let's look at an example. How many permutations are there for the set A, B, C? So again, what I can do here is say, well, the number of permutations, I've got 3 things to choose from. So the number of permutations is just going to be 3 factorial. I'm choosing 3 things from 3. 3p3. 3 factorial is 3 times 2 times 1, which is 6. Next, how many permutations are there for a set containing 5 items? Well, n is 5, so it's going to be, we're choosing 5 things from 5, so it's going to be 5 factorial. So 5 times 4 times 3 times 2 times 1. 5 times 4 is 20, 20 times 3 is 60, 60 times 2 is 120. So there's 120 permutations. Now the number of permutations when selecting R items from n is given by npr, which equals n factorial over n minus r factorial. Now note, most scientific calculators have a factorial key. Some even have a p and a c key. So have a look at your calculator. So here I've got for a set A, B, C, D, how many different ways can 2 letters be selected? So I'm selecting from 4 things. I want 2. So n equals 4, r equals 2. So using my formula, I have 4 factorial over 4 minus 2 factorial. So 4 factorial over 2 factorial. 4 factorial, 4 times 3 is 12. 12 times 2 is 24. 2 factorial is just 2, so my answer is 12. Again, use your calculator factorial button if you have one. Next, if I have 6 vases, how many different arrangements of 3 are there? So it's going to be, sorry about that, from 6 I want to choose 3, so that's going to be 6 factorial over 6 minus 3 factorial, so 6 factorial over 3 factorial. Working that out, I get 6 factorial is 720, 3 factorial is 6, so 720 divided by 6 is 120 different arrangements for the vases. Let's look at some more examples. Assume that a number plate is made up of 3 digits, 0 to 9, followed by 3 letters A to Z with no repetition. How many possible number plates can be created in this manner? Well, if you think about it, the number of plates, we start with digits. So from 0 to 9, that's 10 numbers. So from 10 digits, I can select 3. Because it says got 3 first, and then from my 26 letters I also want to select 3. So from there that's going to be 10 factorial over 10 minus 3 factorial times 26 factorial over 26 minus 3 factorial. So we have 10 factorial over 7 factorial times by 26 factorial over 23 factorial. And come up here as I've run out of room. Using your calculator, that ends up as 720 times by 15600, which gives me a huge number, 11,232,000 number plates. Now remember, if you do have one of those P buttons on your calculator, permutation button, feel free to use it. Okay? You can go straight from this step to this step if you have one of those buttons. Okay? Now number plates usually are our repetition of numbers and digits. Now if that was the case, how many number plates would there be? Well, if you think of it this one, then, oops, red pen, blue would probably be better. Number of plates, well, if you can have repetition, I've got 10 things to choose from for the numbers, and then I have 26 letters, and I need 3 lots of them. So I can have that repetition. So that would give me 17,576,000 plates. Let's look at repeated items. Whoops. Now the number of permutations from a list of n items that contains repeated items, so items that are identical, can be calculated using the following formula. So we have n factorial, how many there are in total, and then divide by the repeated. So where n1 is for one item, n2 is for another, etc. So if we look at an example here, how many permutations are there for the set AA and then BBB? Okay, so from there I have 5 things to choose from, but the number of A's are 2 and the number of B's are 3. So when I work out the number of permutations, well, I have 5 things in total, so 5 factorial, but there are 2 A's and there are 3 B's, and that gives you 10. So it reduces the possibilities because they're a repetition. Next, circular arrangements. Now the number of different circular arrangements of n items is n minus 1 factorial, and that's because when you've got a circle, these two things end up meeting, or whichever way you start and finish. So you always have to take one away. So how many different ways can 4 people be seated around a circular table? Well, it's just 4 minus 1 factorial, which is 3 factorial, which is 6 ways. And that's because it joins. Okay? In contrast, if we had them sitting on a long table, these 2 people aren't ending up near each other. Oh, by the way, in the textbook there's a diagram for this, so if you're not understanding the whole circle thing, have a look in the textbook. Next, the number of distinct arrangements of n items taking r items at the time and allowing repetition is given by n to the power of r. So what I mean by that, from a set AB, how many 4-letter codes can be formed? So n equals 2, r equals 4, so the number of codes is going to be 2 to the power of 4, which is 16. And again, there's a pictorial representation in your textbook. Now look at combinations. Now the thing to remember was permutations, order mattered. So AB was different from BA. Okay? With combinations, order doesn't matter. So when order is not considered, the arrangements are called combinations. So if I just wanted to select a committee of 2, AB is the same as BA. Okay? So we're using combinations when we're choosing teams, committees, lotto numbers, where the order doesn't matter. The number of combinations is given by NCR, which you can also see as that sometimes. So it's n factorial over r factorial n minus r factorial. So let's look at the example. How many committees of 3 members can be selected from a group of 5? So it's going to be 5C3. So 5 factorial over 3 factorial, 5 minus 3 factorial. So 5 factorial over 3 factorial, 2 factorial. Okay, so from there we get, using our calculator, 10. So there's 10 possible committees. Next, any combination of n items will have npn, which equals n factorial over 0 factorial, which equals n factorial permutations. Okay, bit confusing. What this is saying is, how many permutations does a combination ABC have? Well, it means there's 3 things to choose from. So it's going to have 3 factorial, which is 6 permutations. So the combination ABC can be arranged in 6 different ways if we wanted to. Now Pascal's triangle will be used to determine values of the number of combinations, and you can refer to probability I, which is in the appendix for that. Next, committees. If a committee is to be formed with M males and F females, and there are G females and P males to choose from, then the number of different committees or combinations that can be formed will be GC5 times PCM. Don't get too caught up in this. Think about it. The question says how many 3 man and 2 women committees can be formed from a staff of 5 men and 4 women. It's easy to just think, okay, I've got 5 men and I want to choose 3, and then I've got 4 women and I want to choose 2. Order doesn't matter, so it's just a combination. So from there I get 5 factorial over 3 factorial, 5 minus 3 factorial, times by 4 factorial, 2 factorial, 4 minus 2 factorial. So that's 5 factorial over 3 factorial, 2 factorial, times 4 factorial over 2 factorial, 2 factorial, which gears go to the calculator, 10 times 6, which is 60 committees. So go back to it, it's just 5, I want 3 from 5, and I want 2 from 4. Order doesn't matter, so it's a combination. Examples in the textbook, please have a look at those. You might want to watch this video again. I know there's a lot of concepts. Exercises are probability F1 and probability F2.